Hello everyone. In this session, Computer Networks Lab program, we will discuss about the program 5. Develop a program to implement a sliding window protocol in the data link layer. Before the code, I just want to talk about the what do you mean by sliding window protocols. Sliding window protocols are the data link protocols for reliable and sequential delivery of data frames. The sliding window is also used in transmission control protocol. Here we are using multiple frames can be sent by a sender at a time before receiving an acknowledgement from the receiver. Sliding window method is also known as windowing. The sliding window protocols are automatic report request protocols are of two categories, go back and another one is selective repeat. Go backend provides the sending multiple frames before receiving the acknowledgement for the first frame. The next one is selective repeat. This protocols also provides for sending multiple frames before receiving the acknowledgement for the first frame. So let us see the code. So here we are using sender side implementation and receiver side implementation. First we have to go to the sender side implementation. In sender side implementation, import java.io. Import, it tells the compiler to make classes available for us. Java.io, this is the package that contains input and output classes. Star is nothing but import all classes inside the java.io packages. The next step is import java.net.star. This is the package that provides networking related classes. Next we have to declare the class declaration. Public class sender. This defines a Java class named sender. The next step is main method. Public static void main string arguments throw expression. This is the program execution starts from here. Next step is create datagram socket. Datagram socket equals new datagram socket. So here we are creates a UDP socket. This socket is used to send and receive the UDP packets. The next step is get receiver address. Internet address receiver address equals internet address dot get by name local host. Local host means the receiver is running on the same system. For example, converts a host name into an IP address 127.0.0.1. Next one is define receiver port. So here int receiver port equals 9876, the port where the receiver program is listening. Sender will send packets to this port. Next step is set window side. Here int window side equals 4. It defines the sliding window size. Sender can send 4 packets at a time before waiting for acknowledgement. Next step is prepare the data to send. So here byte data equals hello sliding window dot get bytes. So here converts the string into a byte array. Each character becomes 1 byte. For example, hello sliding window. Next we have to initialize the base pointer. Int base equals 0. Base represents the starting sequence number of the current window. Initially transmission starts from the first byte. Next one is we are creating the while loop. Continue until all data is sent. While base less than data dot length. So loop continues until all bytes are sent and acknowledged. Next step is send packets within the window. So here I am using the for loop for I equals base, I less than base plus window size and I less than data length I plus plus. Send packets from base to base plus window side minus 1. So ensures it doesn't exceed the data length. The next step is create datagram packet. Datagram packet equals new datagram packet data I1 receiver address comma receiver port. So here I am sends 1 byte at a time. Here I am using the parameters data. Data is the byte array, I is the offset, it is a sequence number, 1 is the length, 1 byte, receiver address is the destination, internet protocol, receiver port is the destination port. Next I wanna send it to the send packet, socket dot send packet, sends the packet using the UDP. UDP is a connectionless. Next I am receiving the acknowledgement datagram packet, acknowledgement packet equals new datagram packet, new byte 1 comma 1. Here creates the packet to receive the acknowledgement. Acknowledgement contains 1 byte representing the sequence number acknowledged. Next is extract acknowledgement value. So here int acknowledgement equals acknowledgement packet dot get data 0, reads acknowledgement value. So next is slide the window. For slide the window, the code is if acknowledgement greater than or equals base, base equals acknowledgement plus 1. So here if the acknowledgement is valid, move base forward. This slides the window. So next we have to close the socket. The code is socket dot close. It will re-release network resources, hence the communication. Next we have to go to the receiver implementation. So in receiver implementation, public class receiver. So here defines a class named receiver. It will be receiving the end of the communication. The next step is main method. So here the main method are public static void main, string arguments, throw expression. It is the entire point of the program. Throws expression avoids the writing try catch of the socket errors. The third step is create a datagram socket. So here datagram socket equals the new datagram socket 9876. So here I am using the UDP socket. It will be must match the sender's destination port. The next step is initialize expected sequence number. So hint expected sequence number is 0. It will be stores the sequence number of expected next. It will use to ensuring order delivery. Initially receiver expects packets 0. The next step is infinite loop. So here while true, it will be receiver continuously listen for incoming packets. So here receiver continuously listens the incoming packets. The next step is create datagram packet for receiving data. The code is the datagram packet equals new datagram packet new byte 1 comma 1. Here creates a buffer of 1 byte. Each packet carries an 1 byte or 1 sequence number. Next we have to receive the packet. Socket dot receive packet, wait until a packet arrives. Once received, data is stored inside packet. Next step is extract sequence number. Int sequence number equals packet dot get data. It will be reads the received byte. This byte represents the sequence number of the packet. For example, if sender side sends packet 3, the sequence number equals 3. Next step is we have to check the sequence number. If sequence number equals expected sequence number, it will accept the packet only if it is in correct order. Implements flow control and reliability. Next we have to go to the display received packet. The code is system out print next line receiver plus sequence number. This is prints the received sequence number. It will be helps verify the correct packet order. Next, here we are checking the create acknowledgement packet. Create acknowledgement packet creates an acknowledgement packet contains equals sequence number acknowledged packet. Sends the acknowledgement to the sender's IP address, sender's port number. Next, once we create the acknowledgement packet, the next step is send acknowledgement. Socket.send acknowledgement packet. So here sends the acknowledgement to the sender. Sender uses this slides its window forward. The next step is increment expected sequence number. Expected sequence number plus plus. Receiver now expects the next packet. Next is loop repeats. Receiver go back the wait state, continuous receiving the packets definitely. Next we have to run the program.